Hi guys, so today we're going to be looking at Chapter 7, Section 4, Adding and Subtracting Rational Expressions, Part 2. So, the first part, let's say that we're asked to simplify 5 over x plus 4 over 1 over x plus 4 plus 2 over x. So, the best way to go about these type of questions is to start off by simplifying whatever's on the top of your fraction or on the bottom. Seems like on the bottom I can combine those together. So I'm going to do that first. When I do that, I'm going to multiply x to the bottom and to the top. On the other side, I'm going to multiply x plus 4 to the top and to the bottom. That way, at least I get my bottom denominators to be the same. So right here, I'm going to be left with 5 over x plus 4. And that's going to be all over 1 times x, that equals to 1x or x, and that is over x times x plus 4. And then for the other side, I am multiplying 2 times x plus 4. So if I'm going to multiply it, I could just distribute the 2 to both the x and to the 4. Once I do that, now I'm left with x times x plus 4 on the bottom. Okay, so now that you have the same denominators, you can combine them together. If you combine it together, on the bottom you have x times x plus 4. I'm not going to be distributing it. I want to keep it factored because it'll make it easier later on. And then I have x plus 2x plus 8. So x plus 2x, those are like terms, I can combine them. So we get 3x plus 8. And again, we have that top part of our fraction, which was the 5 over x plus 4. Cool. So once you are done writing that down, and I'll make sure it looks kind of nice so that you can see how even it is. The next step is the most important. So we have a fraction line, which could also be considered our division symbol. I'm pretty much saying here that this fraction, 5 over x plus 4, is dividing by 3x plus 8 over x times x plus 4. So basically, you just have two different fractions dividing with one another. So all I need to do is just rewrite it out into 5 over x plus 4, dividing with 3x plus 8 over x plus times x plus 4. So from here, I'm going to change my division symbol into multiplication, flip my fraction, and so I get 5 over x plus 4 times x plus 4 over 3x plus 8. Now again, the reason why I don't want to deal with distributing the bottom and keeping it as a factored form is solely for this reason. So when I combine them, I get 5 times x plus 4. And I'll leave that in the parentheses so that I know that that entire thing is a factor. On the bottom, I have x plus 4 times 3x plus 8. And so because I didn't combine it, I ended up seeing that the factors x plus 4 can be canceled out, and I'm left with my simplified fraction 5x over 3x plus 8. Now we're not done yet because again, you have to understand where your restriction is. So my restrictions are going to be from the domains x plus 4 and x. So x cannot be equal to 0 in both cases. I gotta solve for it, so this becomes x cannot equal negative 4. This one is still x cannot equal to 0. So let's see about my simplified restriction or domain, and let's see if it would overlap. We have 3x plus 8 not equaling to 0, and I'm solving for x. Subtract 8 on both sides, I get 3x cannot equal to negative 8. Divide 3 on both sides, And I'm left with x cannot equal to 8 over 3, or negative 8 over 3. So that's definitely not overlapping with my original restrictions. And so because of that, from my simplified answer, I have to say that our simplified fraction is 5x over 3x plus 8, with the restriction that x cannot equal to negative 4 and x cannot equal to 0. And that would be my final answer. Okay, next problem. Very similar. Again, we have simplifying 3 over x plus 5, and that is over 2 over x minus 3 plus 1 over x plus 5. So again, with the bottoms, I can combine it since they're adding fractions. All I need to do, multiply x plus 5 to both the top and the bottom. And to the other side, I'm just going to multiply x minus 3. Again, I will only combine anything or distribute anything on the top. I will leave my fractions or factors alone on the bottom. So we get the 3 over x plus 5, not really dealing with it yet. And on the bottom, we have 2 multiplying with 5 and x, so that becomes 2x plus 10. On the bottom, we have our new denominator, x plus 5, x minus 3, adding with 1 times x minus 3 is just going to be x minus 3 over x plus 5 times x minus 3. And then from here, I'm just simplifying the inside over here. I'm going to combine any like terms that I see. So the like terms I see are going to be positive x and positive 2x. 2x plus x just gives me 3x. Positive 10 and negative 3, 10 minus 3, that equals to 7. On the bottom, I still have my x plus 5 times my x minus 3. On the top is where I have 3 over x plus 5. So now I have my simplified top and bottom. Now that it's simplified both on the bottom and the top, I am going to rewrite it into the division expression. 3 over x plus 5 is dividing with 3x plus 7 over x plus 5 times x minus 3. And again, I am going to flip over the division sign into multiplication, make the fraction a reciprocal, and we get x plus 5 times x minus 3 over 3x plus 7, and this stays the same on the left. From here, I could probably cancel out the x plus 5s, and I'm going to be left with 3 times x minus 3 over 3x plus 7. Done. Last thing, find your restriction. You have x plus 5 cannot equal to 0, and x minus 3 cannot equal to 0. So from here, I'm going to subtract 5 to both sides, add 3 to both sides, and I get x cannot equal to negative 5, x cannot equal to positive 3. If I look at my simplified domain over here, it says 3x plus 7 cannot equal to 0. So solve for x. It's definitely not going to be overlapping with our original domains, because we get here negative 7 dividing. That's not going to help at all. So again, because our restriction is not the same, that means that I need to place additional restrictions on my simplified answer, which would be x cannot equal to positive 5, x cannot equal to, and that wasn't supposed to be positive 5, that was supposed to be negative 5. X cannot equal to negative 5, and x cannot equal to positive 3. And so that would be my final answer in the end. You would get the simplified fraction with 2 different restrictions added on. Cool. So hopefully this helped. Good luck.